Welcome to a new test and teardown video. This time we're going to look at a Hameg oscilloscope called HM1507. It's an analog digital scope, so this means it is capable of doing both the analog mode and sample storage mode. Its bandwidth is 150 megahertz in analog mode and 200 megasamples in digital mode. And of course, on Hamegs, you got this component tester. Those are pretty nice. Cursor, you can move this up and down. I don't really understand how you move this up and down. There isn't any, I don't dare to push it that far. Don't really understand that yet, but we are probably going to figure this out when we turn it on. This one is from about 1999. So it is actually pretty old already, but it is in a fantastic mint condition. It looks like it's brand new all over. I don't see any nasty fingers or anything rubbed off anywhere. And I was promised this one should work perfectly fine. Here on the back, you see this the standard IEC connector, and then you take your cable and wind it around the feet and stick in the connector here. And look at that. It's support holding most of the connector styles except USA and also France and some other countries where you got 3 pins here in the middle. But other than that, it can hold the cable, and you know where you have it. So I was saying 1999, yes, the week 50 and 1999, and then this is the -3 version of this instrument. And there's a serial port right here. And the serial port supports different features like instrument controlling and also downloading of the captured data. So that is pretty fascinating. And of course, this instrument was from 1999, so that means the supplied PC software is for Windows 3.x and also 95 and NT. So obviously you're a little bit, I don't know if we will be able to figure this out today, but all the serial commands, they are published, and we can just continue to control this via a serial port. So it shouldn't be a big problem. So this is going to be my first power on, and I think this is how I really love to present those videos, because then I got no previous knowledge or skills or anything about this oscilloscope, and then it's more fun to look real dumb or something like that. I don't know. So we got a picture. So intensity is here. Focus should be, of course, adjusted. All that is fine. I think there is a readout. So you push. Yes, this is how it is. So this is the analog. This is the readout, and there you have that is it. All right, so far so good. So let's plug in. I didn't touch anything right, and it's of course everything is completely digital, so when you turn something, you'll hear clickety, 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 right? So if I put in a signal, and I just hit auto set. Bleepity bleep. Okay, we got some nice sounds. Oh, look at that. It reads out the frequency. And it says we are in 10 volt. We got probably some cursors somewhere. And now, here we go. That will be the cursors. Now, let's, So that is this one. Then how do I select? There is no up and down. So this is how my cursors work. And then I push Now I feel completely dumb. Is it that one? Yeah. And then I move the other one. So this is a manual thing. So let's try and put these all the way wrong and then hit auto set again and see if there's any. Yeah. Now it's another result and it puts the cursors exactly where the frequency is. I kind of like that. So let's put in 2 kilohertz and see if it still works. Yeah, definitely nice. So I've been consulting the manual a little bit and I finally figured out exactly how this works. So the save and recall here, when we push around here, we have a little indication here at the screen. It's called save 1, 2, 3, all the way to 9. So that is instrument setups. All the things here is completely digital, remote controllable and whatnot. So of course you can save and recall all your configuration settings. So this has nothing to do with the screen or the tracks or anything like that you want to save, right? So let's try and play with this. We have we are in digital mode. We see the digital mode because one of these lights up. So we are now in digital mode. Okay, so let's move this one to show that we have a live update going on here on channel 2, whatever. So if we turn on reference 1, I just previously saved this one. So if I move this one up to that line, for example, and hold, now it's saved this one again. So now I've overwritten memory 1 and I can now move it down to the next line. Okay, so let's select memory 2 and override memory 2. So let's move this one down here. And now I can enable both memory 1, 2 and the live signal at the same time. So this is a very useful feature when you're playing around with some analog or digital signals and want to see changes in whatever you're doing. Also, you need to understand that what you're doing here is you're saving this memory to display memory and not to a live waveform that is, well, the easiest way to see the difference is if I change the time base. See, the stored waveforms, they remain exactly the same and they are not affected by the time base. So that is a very important thing when you're doing investigations on your and actually using reference signals. Of course, you cannot poke around with time base. Obviously, also if you change your channel's settings here, you ruin the trackability or stuff like that, right? I think that makes pretty good sense. So this is a digital mode. So let's try and switch to analog mode by holding this store button in here. See, now you're in analog mode. And the cool thing about analog mode, I really want to show, here is the time base. And I don't know if you can see, no matter how fast I poke around with anything here, I got a complete live update response. And it's of course the same here. Incredible live update, of course. So let's switch back to digital mode. See? So here's your beep, 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 beep. So it takes half a second from your knob to screen update, and it is the same in whatever. There is a little bit of time from acquisition to screen update. That is just the way the digital interface works and the memory works and all that kind of stuff. So we need to get a little bit used to that. In some of the time-based settings, let's go back to analog mode here. I don't know if you can see, we have a the readout and all that. If I turn on the cursors, we can of course, this is the brightness of the screen, and then we change the readout brightness. It's probably blinking a little bit on the video. I don't really see this in real life, but this is because there's multiplexed. And in some of the time base settings here, I get a big sort of interference, like it's probably visible here. So there's a way to turn off the readout, and then you get all your speed, all your screen is now the analog. That is definitely useful, and it speeds up everything even more. So let's play a little bit with the frequency range, because this one was supposed to do 150 megahertz in analog mode. So this is a 100 kilohertz signal, and I like to adjust the amplitude to 100%. We got those little dots here, and they are exactly designed to do that. So here is 2 volts peak, and that is 100 kilohertz. So let's play with analog mode, and then crank this up to 1 megahertz, and then of course we dial the time base. See, this is exactly the same. Okay, so 10 megahertz, and it's exactly the... Oh, did you hear that? So that means I am now in full speed mode here, the finest. But I can of course push this times 10. So this was 10. Well, let's crank up the frequency to 100. Oops, and 110. And now we have reached 90% and 10% here. So this is 110 megahertz analog bandwidth, and it is exactly the same on channel 1. So let's try and do exactly the same in digital mode. Okay, let's start 100 kilohertz, exactly like before. We go into digital mode, and then we see that it is digital. You can, of course, in digital mode, also turn on the cursors and all that kind of stuff. When you're poking around with different time bases and different frequencies, the cursors aren't really that much useful, because you need to go and manually move them all the time. There isn't any auto tracking. The way that this is tracked is by using auto set. That also updates the cursors to automatically measure what it is you got. So that is why there is this little push here, and then you turn off the cursors, but then you still have all the readouts for whatever you're doing. So let's try and see, of course, the same amplitude, and all that is perfectly correctly adjusted. So let's go to 1 megahertz, and here we go, the time base. I am in times 10 already. I don't know if that is visible, sorry about that. Here we go. This one is times 10. And that, of course, also works in digital mode. So this is 10 megahertz. And I think we have now the finest, the fastest time base, and times 10. And it says 10 nanoseconds per division, and all that is fine. So this was 10 megahertz, and let's try 20. Ooh, and 30, and then it goes. So 30 megahertz in digital mode, we have a -3 dB, and we have a very unstable readout, and that is of course due to the sample rate. The sample rate is 200 megasamples, and that is interfering with the sampling and all that kind of stuff, and the recreation filter tries to make a nice sine wave and all that kind of stuff. So obviously it's going to look exactly like that. So I think you cannot use it for any faster than 30 megahertz like that. It's going to look really funny and unstable. You could of course find frequencies where it should go stable. I'm not super lucky with that. So we're back to 10. 10 is also really, really good, and especially when I turn off this time 10, it goes really nice and fine and stable. There's another very important thing that I really always love to show when it comes to evaluating scopes and their usability and all that kind of thing, and that is the pulse. So here's a 1 microsecond pulse, and the repeat is 100 kilohertz, and we are now in digital mode. And of course, with a digital scope, they're able to handle everything before the trick. And since this is a pulse, here we see the trigger point. I really love those digital scopes that shows the trigger point. See, if I go over the trigger point, we have now a steady frozen signal, and then we go back and it's alive. You can also go in, this is normal mode. You can also go in auto mode and all that kind of stuff with this one. Just push this button, right? So digital mode, we have plenty of time. And we can zoom in. We got really nice rise time here on the pulse modes. So here we go with that. So let's try and see the analog mode. Now it's getting a little bit interesting, right? In analog mode, it's not storing anything. There is a time base, you trigger, all that kind of stuff. So let's remove the readouts. And then let's zoom in on our pulse. You see, we have actually a little bit, I can move the position here. So now we can see we have actually a little bits of the signal before the trick. And that reveals we have a delay line inside this unit. And if we zoom in a little bit more, here we are at 50 nanoseconds per division. We see we have a delay line of almost 50 nanoseconds. Isn't that just fantastic? So we see the rise time of the signal we are triggering on. And that is a very useful feature on an analog oscilloscope. So I think I've been playing enough with this fantastic scope. All the features works. It's super duper accurate. And I'm really, really happy about all that. But let's have a little look inside and see how it's designed. So now we are inside this fantastic oscilloscope. And here at the corner, we have a switch mode power supply. This one also generates the high voltage and all the logic power supplies. I don't really plan to open the power supply because it's just kind of boring. But the main board is here, and it's doing all the software features and whatnot. We got the two analog inputs from the front stage amplifiers. And I believe that will be pre-amplifying and then 80 converters. And they go into a Xilinx Spartan FPGA. And that one, of course, samples all this and stores it parallel into all this RAM here. So this is our super fast capture system. And I believe that one is a little microcontroller or a CPU. That will be the ROM and that will be the RAM to run the application. Got a little interface chip right there. We got EEPROM for settings and stuff like that, right? And the display memory, that will be the display memory. Everything we see on the screen is handled right here. So that will be the memory chips and another little FPGA or controller for that. And here you go with the DA converters that is actually handling the display. So the display is always in XY mode, so to speak, when the digital modes are enabled. And in analog mode, this one is of course only doing all the curves and cursors and readouts and stuff like that. The serial output, just a little serial port driver chip. Nothing fancy about all that. And the back side of the front panel. I don't understand exactly what this little add-on board here is doing. There's just a little chip and a little oscillator. Strange. And I find a little piece of plastic right there. And I believe that is the little broken part that is missing. See, here it is, and here it's missing. But it sort of sticks quite well here without this part. So maybe that's why they just gave up gluing it. There's, of course, this is a classic thing with Hameg and many other oscilloscopes. This is the main power on-off switch. And it goes via a long stick all the way inside the power supply. See, that is a good thing. Now we don't need to carry or transport mains all the way here and have a little switch here. So that is a very good way to do it. I totally love that. And this is the bottom side of the oscilloscope, analog input section here, and we got it's completely relay controlled, attenuators, amplifiers and all that. And then we go in here to the amplifiers right here, and into that little cable here we got some analog switches as well. And there isn't a lot of fancy things on this board, other than I find it a little bit funny. We got Altera EPM1507-3, so that will be a pretty fancy CPLD programmable gate array, and you can do I don't know how many thousands of gates and counters and whatnot you got in these. And this one is marked with a little colored dot, and the other one here got 4 colored dots, and this is the same type. So they will be doing all sorts of handling what is going on this analog board. So in analog mode, this cable here is important. So this is where we transport all the analog stuff via a delay line. I don't know if it's visible, but we got 2 thin wires that goes in here, and they are twisted around a core to make the signal length as long as possible. And then this cable goes into that hole there, and it comes out. Oh, let me see if I can do this. And it comes out here and it goes right here. So this is, of course, the vertical amplifier. And then the drive to the deflection. That is high voltage right there. So this is why you have these good, safe isolation distances. And there's another really cool thing, because this one can go pretty fast, right? Then this vertical signal comes directly out of those transistors to this resistor system right here. And this is to drive the deflection plates in correct impedance. And because it's high voltage and rather high power as well, and this is always how you do it, to handle the impedances and the power and the voltages and all that. And then you go directly into the deflection plates of the CRT. Pretty nice. I think I forgot to show XY mode. And of course, when it is in XY mode, it will go into analog mode. We still got the readout. We can turn off the readout, and yes, we can. So now it is true analog XY mode. And that is a very, very cool feature, because it's really working good in XY mode. And that is where all digital scopes, all modern scopes, even this one here, just completely fail. They are useless for XY mode. And here it's just so fantastic good and stable. Yeah, I was playing a lot with the variable mode. That is some sexy mode, because when you have, see, normally you go like clickety clackety click, but you can also, see, click and hold. Now you're in variable mode, and then see, you have a high resolution like that. Completely software controlling everything in the analog section. I kind of like that a lot. So I think that is what I want to show. Thank you very much for watching. Hope to see you soon again. Bye bye.